It's your friendly math tutor, Miss C here, and today we are graphing quadratic equations in minutes using our first method, making a table. So before we get started on the graphing, I want to draw your attention to our equation right here. This equation is written in factored form, and factored form is an important form because it tells us what our roots are. Sometimes we call roots x-intercepts, sometimes we call them zeros, but they're essentially the same thing with a few nuances mathematically. So this is going to influence how we create our table. So I'm going to go ahead and draw my t-table that we're going to use to plot. I'm labeling the left side as x because those are the x values we're going to input, and our right column is y values, and that's what our output is going to be. So here's how I like to do this. So knowing that this is factored form, I know that when this whole term or this whole product equals 0, right? So whatever I put into x makes this 0, the whole equation turns 0. That means whatever I put in for x made y 0. That means that those are my x-intercepts. So I'm going to write those down on my table first. So if I put 4 in for x, 4 minus 4 is 0. So I'm going to go ahead and put that on my table. I want that to be there because when I do that, I know I have an x-intercept there. Likewise, if I put negative 2 in for x here, negative 2 plus 2 is 0. 0 times anything is 0, and that makes y 0. So those are 2 points we're definitely going to want to graph. I also think an easy point to graph is always the y-intercept. So I think intercepts are always a great start if they're easy to find. And so all I'm going to do for this one is I'm going to plug 0 in for x. So when I do that, I'll write this over here. We get 0 minus 4 is negative 4 times 0 plus 2 is 2. That means my y-intercept is negative 8 when I multiply those together. I also know just by looking at this graph that I don't have a negative in front of my factored form, and I don't have any negative x's. And what that tells me is my parabola is upward facing. It looks like a U, an upward facing U with arrows on the ends. So what that means is I want to pick two other values on the opposite side of these numbers. So I'm going to just pick 5 here and negative 3 here. So a little smaller because that's just going to help me get the width of my parabola correct. So I'm going to go ahead and come down here, and I'm going to quickly do this in my head. 5 minus 4, I'm substituting 5 everywhere I see x, is 1. 5 plus 2 is 7. 1 times 7 is 7. We know that parabolas are symmetrical, but just to prove that, we have negative 3 I'm putting in for x, so negative 3 minus 4 is negative 7. Negative 3 plus 2 is negative 1, and I get 7 out. I have 5 values now. I'm set to graph. I'm going to start with negative 3, and I'm going to go all the way up to 7, which is right here. Then I'm going to do negative 2, 0, 0, negative 8 right here. That was not a great point. 4, 0, and 5, 7. So be really careful when you graph this because this y-intercept is not our vertex. In fact, our vertex would be between this point, is the midpoint between this point and this point. So if we wanted to know our vertex, I could count in 1, 2, 3, and then 1, 2, 3. Our vertex is going to happen when x equals negative 1. So it's going to be here. So make sure that you don't make your y-intercept your vertex point. If you really want to know what the vertex is, you could also add a negative 1 to your table and do that, but we've already got 5 values, so we're not going to do that. So now I'm just going to connect these points in a U. And remember, this is a sketch. It's not completely accurate. And that's what my parabola should look like. Although I guess I should have probably done that in a different color because that's very hard to see. And look, I picked yellow again. Goodness, and now it's even crookeder. Okay. All right, that is the way that you can make a table with factored form. Let's look at how you can make a table to sketch the graph of a quadratic function in vertex form. Our second equation is written in vertex form. So in this form, we know what either our lowest or our highest point is. So before we get making our table, a couple things. there's this negative sign out in front of our parentheses. That means that this parabola is upside down, or reflected more precisely, about the x-axis. So it looks like this. Okay, so the vertex represents the highest or the maximum point on our graph. Okay, and I know that I can easily find the vertex, and then we have some like points of symmetry about the vertex, right? So the vertex is our line of symmetry, and then we have y values that are the same and symmetrically distant from that line of symmetry. So that's going to influence what we put in our table. So let's go ahead and draw our table with our x and our y values. And the first value, x value I'm going to put on here is the value for the x coordinate of my vertex. And the way we do that, hopefully you remember, is that we make this parentheses 0. So x has to take on the value of 1 to make this parentheses 0, because 1 minus 1 is 0, 0 squared is 0, 0 times the negative is 0, and then we add 5, and that tells us what our y value is, which is 5. So this is our vertex. And now, because we know parabolas are symmetrical about the vertex, I'm going to go ahead and put x values just one below and one above the vertex. So this x value also happens to be our y-intercept. So that's always a good one to put on. So I'm going to go ahead and do that in my head really quick. I know there's a negative hanging out front. So 0 minus 1 is negative 1. Negative 1 squared is 1. Okay, plus 5. And that tells me that I have a value of 4 here. Now, I could do the exact same thing with 2, but I know that this is going to be a symmetrical value because it's exactly 1 unit away from my vertex. So this is going to take on a y value of 4 as well. Now, I'm going to have negative 1 here and 3 here. So now we're 2 away in both directions from our vertex. So I'm going to just pick 3, and I'm going to go ahead and calculate out the value. And then I'll also know the y value for negative 1. So when I do that, 3 minus 1 is 2. 2 squared is 4. And I already had my negative hanging out there, plus 5. So that gives me negative 4 plus 5 is 1. If that's 1, this has to be 1. So let's go ahead and graph. So our first point is 0, negative 1. Or sorry, negative 1, 1. It's reading vertically. Our next point is our y-intercept of 0, 4. Then we plot our vertex of 1, 5. And this point represents our maximum. Okay, then we have 2, 4. So remember how we said that these points are equidistant and symmetrical about the line of symmetry, which passes through the vertex. You can see we have 2 y values that have the value of 4. And then we have 3, 1. Okay, again, 2 y values with the of 1. And now we're just going to connect these guys to make a lovely little U, upside down U. And that is a quick sketch of a graph written in vertex form.